Sound can't travel through space. That's basic science. A vacuum has nothing to carry it. But in 2022, NASA released an audio clip which makes no sense from a black hole 240 million light years away. Millions of people listened. Most called it the scariest thing they'd ever heard. That clip was pitched up by a factor of 144 quadrillion, just so human ears could process it. And it's not even close to the scariest sound we've found out there. The universe doesn't make sound the way we understand it, but it vibrates, it pulses, it rings. And when scientists figured out how to translate those vibrations into audio, they heard things that shouldn't exist. Some recordings come from a billion light years away. One was captured right above our heads, and during World War II, it made military radio operators believe they were picking up enemy signals. They weren't listening to the enemy, they were listening to the planet trying to tell them something. During World War II, radio operators on long-range communication lines started hearing something strange. Whistling tones, descending pitches, sometimes a sound like birds singing in a forest at dawn. Not static, not interference, something that sounded almost alive. They assumed it was enemy transmissions, coded messages, secret signals. It wasn't. What they were hearing was Earth's own magnetic field. High above the atmosphere, in the region called the magnetosphere, electrons from the sun get trapped in Earth's magnetic field lines. They spiral along those lines at thousands of kilometers per second. As they move, they create waves that happen to fall in the same frequency range as human hearing. For decades, nobody knew what to do with them. Then NASA decided to listen on purpose. In 2012, they launched the Van Allen probes directly into Earth's radiation belts, and for the first time, captured the sound clearly from space. This is what they recorded. That's not a recording from a sci-fi movie. That's real, directly above you. Scientists call it chorus, chirps, rising tones, strange little melodies created by nothing but charged particles spiraling through invisible magnetic tunnels above our heads. It sounds almost peaceful. It's not. The chorus is a signal. When it gets louder and more chaotic, it means the radiation belts around Earth are intensifying. Solar storms are feeding energy into the magnetosphere. More particles are being whipped up to dangerous speeds. The chorus is beautiful. It's also a warning. When Earth sings louder, it means the radiation is climbing. And those are sounds from our own backyard, a few thousand kilometers up, still inside Earth's protection. Step outside that protection, and what you hear stops making any sense at all. 240 million light-years from Earth, in the center of a massive collection of galaxies called the Perseus cluster, sits a black hole hundreds of millions of times the mass of our Sun. And it's been humming. Not metaphorically, it produces an actual note. In 2003, NASA's Chandra X-ray Observatory detected pressure waves rippling outward through the hot gas surrounding this black hole. Scientists analyzed the waves and found a frequency, a B-flat, 57 octaves below middle C. To understand how low that is, a piano covers about 7 octaves. This note sits 57 below the middle of that range. One complete cycle of this sound wave takes 10 million years. Let that sit for a second. One note, still playing, since before complex life existed on Earth. Your ears can't hear anything with a cycle longer than about 1/20th of a second. In 2022, NASA's sonification team took that frequency and raised it by a factor of over 144 quadrillion, compressing 10 million years of vibration into something that fits inside a human ear. Then they released it. This is what millions of people heard.
went everywhere. People called it haunting, evil, like something that shouldn't exist. And it is unsettling. But most people stopped at, "This sounds creepy," and never asked the deeper question. Why is the black hole making this sound at all? And what is the sound doing? The Perseus cluster contains over 1,000 galaxies. Between those galaxies floats a thin fog of gas, heated to millions of degrees. Under normal conditions, that gas should slowly cool down. As it cools, it should collapse under its own gravity, and as it collapses, it should trigger enormous bursts of new star formation. None of that is happening, and for years, nobody could figure out why. The reason is the sound. The pressure waves rippling outward from the black hole carry energy. That energy transfers into the surrounding gas and heats it back up. The black hole's hum is actively preventing the gas from cooling, preventing it from collapsing, preventing new stars from being born, across hundreds of galaxies. Think about that. A vibration, a single note, is deciding whether entire star systems get to exist, whether planets form, whether there's anywhere for life to begin. One black hole, one note, playing for billions of years, controlling the future of 1,000 galaxies with sound. A sound that old should feel permanent. It isn't. Nothing in this video is. That should be the strangest thing in this video. It isn't. On September 14th, 2015, early in the morning, a signal arrived at 2 detectors in Louisiana and Washington state. It lasted less than 0.2 of a second, and it was the most significant sound ever recorded in the history of science. The detectors belong to LIGO, a pair of instruments that don't look anything like telescopes. They don't use lenses or mirrors aimed at the sky. They use lasers. 2 perfectly straight laser beams, each running down a tunnel 4 kilometers long, bouncing off mirrors at the end and returning to a single point. Here's what they're listening for. When a gravitational wave from deep space passes through Earth, it stretches space itself by amounts so small they shouldn't be measurable. One tunnel gets slightly longer, the other gets slightly shorter. The lasers detect the difference. The margin they're working with is absurd. The difference they need to detect is about 1/10,000th the width of a single proton. And on that September morning, both detectors picked up the same signal, 7 milliseconds apart. A rising tone, a chirp.
What you just heard was 2 black holes, each about 30 times the mass of our sun, spiraling into each other 1.3 billion years ago. They had been orbiting each other for millions of years, slowly getting closer, moving faster until they merged into one in a fraction of a second. Now, here's the part that doesn't get enough attention. At the moment of collision, the power released in gravitational waves momentarily exceeded the combined light output of every star in the observable universe. Every star, in every galaxy, all at once. And it was completely invisible. No light, no radiation you could see or feel, just a ripple in the shape of space passing through everything in its path. And nobody saw it. Nobody felt it. The only way we knew it happened was because space itself bent just enough for a laser to notice. In that fraction of a second, roughly 3 times the mass of our sun was converted directly into energy. Not heat, not light, pure gravitational radiation. Nothing else in the universe converts mass to energy that efficiently. Not nuclear fusion inside stars, not matter spiraling into a black hole's disk. Nothing even comes close. Einstein predicted these waves a century before we heard them. He also thought detecting them was impossible. The math said yes. The engineering said no way. A century later, we heard two black holes destroy each other from across the observable universe. Since that first chirp, LIGO and its partner observatories have recorded over 100 similar events, each one a unique sound, each one the signature of something ending. And all of them, every single one, are just background noise compared to what came first. But every gravitational wave, every black hole hum, every chorus from Earth's magnetosphere, all of them play against a backdrop, a deeper, older sound, one that was playing before stars existed, before galaxies formed, before light itself could travel freely. Every other sound in this video is a translation. Electromagnetic waves, X-ray pulses, gravitational ripples, converted into audio so human ears can process them. None of them were actually sound. They were data made audible. This one is different. In the first 380,000 years after the Big Bang, the universe was so dense and so hot that it behaved like a thick fluid. And in a fluid, sound can travel. Light couldn't move freely. Matter and radiation were packed together so tightly that pressure waves, real physical pressure waves, could move through the entire cosmos. Sound waves. Actual sound waves traveling through the early universe like sound moves through water. These weren't small vibrations. They spanned hundreds of thousands of light years. Ripples of pressure that squeezed matter together here, stretched it thin there, and decided where galaxies would eventually form. Every galaxy, every star, every planet. The sound waves literally shaped where the universe's structure would form. And those waves left a mark. When the universe finally cooled enough for light to escape, 380,000 years in, the pattern of those sound waves was frozen in the oldest light we can see, the cosmic microwave background, a frozen record of the moment the universe became transparent. And embedded in its tiny temperature differences is the record of every acoustic wave that was still ringing when the music stopped. In 2013, physicist John Kramer at the University of Washington took that data and did something no one had done before. He didn't translate electromagnetic waves into audio. He reconstructed the actual pressure oscillations that once moved through the cosmos, the original sound. Not a metaphor, not a conversion, a reconstruction of real acoustic waves from the birth of the universe. This is what it sounds like. A low, descending roar, starting higher, dropping lower as the universe expanded and the waves stretched. The sound of everything beginning. You're not listening to a translation. You're listening to something that actually happened 13.8 billion years ago. For 380,000 years, the cosmos rang like a bell. Then it cooled, the medium thinned, and the sound stopped. But here's what makes this the scariest sound of all. It's disappearing. The cosmic microwave background, the light that carries the frozen imprint of those original sound waves, is still detectable today. But the universe is expanding. The wavelengths are stretching. The temperature is dropping. Right now, it sits at about 2.7 degrees above absolute zero. Scientists believe that trillions of years from now, it will have stretched to wavelengths so long and energies so low that detecting it would be beyond what any instrument could achieve. The fingerprint of creation will be erased. The only real acoustic sound the universe ever made, the roar of everything beginning, will fade below detection, gone, as if it never happened. And no civilization born after that point will ever know it existed at all.
So here's where we end up. The black hole clip that went viral, the growl from the Perseus cluster. It's not the scariest sound in space, not because it isn't unsettling, but because there's something worse than a growl in the dark. Earth hums a warning that radiation is building. A black hole sings a single note that prevents stars from being born across 1,000 galaxies. Two collapsed objects spiral together and shake the fabric of space hard enough for us to hear it from over 1 billion light-years away. But beneath all of those, older than all of them, is a low roar that's been fading for 13.8 billion years. The sound of everything beginning. The only real sound the cosmos ever produced. And it's going quiet. The scariest sound in space isn't a scream. It's the moment the last echo of the beginning stretches past what anything in the universe can hear. And we are living in the final era where it's still there. Barely, but still there. If this changed how you hear the universe, subscribe to Velix Career. There's a lot more out there, and I'll see you in the next one.